How different game engines impact the final product. Game engines are the backbone of modern video game development, and the choice of engine significantly affects the final product in terms of performance, visuals, and gameplay experience. Game engines provide the necessary tools and technology to create interactive experiences, from physics simulation to rendering graphics and handling inputs. Different engines have unique strengths, and developers choose them based on the kind of game they aim to produce. Here's a look at how different game engines impact the final product. 1. Graphics and visual quality. One of the most noticeable ways game engines affect the final product is in the visuals and graphical fidelity. For example, Unreal Engine is known for its high-quality rendering capabilities, producing photorealistic environments and characters. Games like Fortnite and Gears of War showcase Unreal's ability to deliver stunning, high-definition graphics. On the other hand, Unity is highly versatile, used for both 2D and 3D games, but is typically chosen for projects where top-tier visual fidelity isn't the primary focus. Unity is often used in indie game development, with games like Hollow Knight and Cuphead relying on its flexibility for stylized art. 2. Performance and optimization. Different engines handle performance and optimization differently. Some engines are more resource-heavy, meaning that while they may produce visually stunning results, they can be demanding on hardware. Unreal Engine, while capable of amazing visuals, often requires powerful hardware to run at full potential. Conversely, engines like Godot and GameMaker Studio are optimized for smaller-scale projects. They are designed to be less resource-intensive, making them ideal for mobile games or indie titles with simpler mechanics and graphics. This makes these engines excellent choices for developers focused on performance efficiency over graphical complexity. 3. Ease of use and developer tools. The ease of use offered by different game engines affects the development process and ultimately, the final product. Unity, for example, is often praised for its user-friendly interface and extensive documentation, which allows developers to prototype quickly and iterate on ideas efficiently. This can lead to faster development cycles and more polished games. Meanwhile, CryEngine offers advanced features but comes with a steeper learning curve, which might slow down the production process for smaller teams or individual developers. However, once mastered, CryEngine can deliver visually breathtaking games, like Crysis, known for pushing the boundaries of what hardware can handle. 4. Gameplay mechanics. Some engines are better suited for specific gameplay mechanics. For instance, RPG Maker is designed specifically for creating role-playing games, providing developers with pre-built assets and tools to create story-driven games easily. While it limits customization compared to more robust engines, it allows for faster development of RPG titles. Frostbite, used primarily by EA, is optimized for first-person shooters and large-scale battle environments. Games like Battlefield showcase its ability to handle destructible environments, massive multiplayer modes, and fast-paced combat, offering an experience tailored to the shooter genre. 5. Cross-platform capabilities. The ability of a game engine to support multiple platforms impacts how widely a game can be distributed. Unity is well known for its cross-platform capabilities, making it an ideal choice for developers looking to release games on PC, consoles, mobile, and even VR platforms. This flexibility allows developers to reach a broader audience with minimal changes to the game's codebase. In contrast, some engines, like RPG Maker, are more limited in terms of cross-platform compatibility, often requiring additional work to port games to different platforms. This limitation can reduce a game's market potential if the engine restricts distribution options. 6. Community and asset support. A strong developer community and access to pre-built assets can significantly affect a game's development and final product. Unity has a vast asset store and an active developer community, allowing developers to easily find and integrate assets such as character models, environments, and animations. This can speed up the development process, reduce costs, and enhance the game's final quality. Unreal Engine, similarly, benefits from an active community and a robust marketplace of assets. The availability of these resources helps developers overcome technical hurdles, leading to higher quality final products. 7. Cost and accessibility. Some game engines are more accessible to developers based on cost and licensing. Unity offers a free version with limitations, making it an attractive choice for indie developers or those with budget constraints. Similarly, Godot is an open-source engine, offering full access to its tools at no cost, which can be a major advantage for smaller studios. Engines like Unreal Engine, while offering a free-to-use model, require royalty payments once a game surpasses a certain revenue threshold. This can affect long-term profitability and influence the decision of developers when choosing an engine. 8. Modding and community involvement. Certain engines foster a modding culture, enabling players to create and share content, which can extend the life of a game. Bethesda's Creation Engine, used for games like Skyrim and Fallout 4, has an active modding community that keeps these games relevant years after release. The ability for players to mod games can lead to a more vibrant community and a richer experience, which ultimately adds value to the final product. The choice of game engine is a critical decision that affects nearly every aspect of the final product, from graphics and performance to gameplay mechanics and cross-platform capabilities. Developers must weigh the strengths and weaknesses of different engines to ensure that they align with their project's goals, budget, and target audience. Whether aiming for high-end graphics, smooth performance, or rapid prototyping, the right engine can make all the difference in delivering a successful game.